Nice cup of tea. Nice cup of tea. Hi, you caught me practicing polyrhythms, where in music we have two parts acting completely separately on a different rhythm. So my left hand's counting 2 to the bar and my right hand's 3 to the bar, making my conscious mind do two things at once, which is hard. With the same problem in building projects in a microcontroller, sometimes we need the processors to do more than just one thing at a time. We have 2 cores on a Pico, so we can quite easily do 2 things. How about if we want to do more though? For some problems, designing code in separate tasks makes the problem significantly simpler. That is where real-time operating systems, RTOS, come in. They give us the frameworks to allow us a lightweight task to run concurrently, along with the primitives to communicate between those tasks. In this video, I'm going to explore an example using FreeRTOS Kernel, an open source real-time operating system library. When we first start with a Pico, we normally write a blink program. This has 2 parts: the initialize and setup of the GPIO pad to be an output, then a loop to turn on and then off the LED with a delay in between. This assumes we've connected the LED to GPIO2 via a 75 ohm resistor in a sourcing power pattern, so setting GPIO2 to high or 1 will result in the LED going on. Blink isn't that exciting though. But what if we wanted to blink multiple LEDs? Well, that's fine, we just update the loop. Unless we want them to blink at unrelated speeds, polyrhythms that I find so hard in piano. Then a generic approach is quite hard. We would need to find a common time pulse and organise the loop around that. It's quite doable, but it requires some work. If we do this in FreeRTOS, then each of our blinking LEDs can be controlled by a separate task. The code to manage this is just the same as the code for blink. We do the same setup of our GPIO pad to be an output. We then run the same for every loop and change the state of the GPIO pad from on to off between delays. The only difference here really is the delay approach. We now tell FreeRTOS we want to delay rather than telling the SDK. That allows the scheduler in the background to let another task run while we sleep. We need to create our tasks and start them up. I do that through a boot thread, or main task as it is called in this example. It just creates them, giving them the GPIO pad to use and the delay speed in ticks that we want it to use. Then we can start each of the blink workers' tasks. They get names and priorities, but nothing to worry about. That gives me a Pico where I have these different blink speeds going on. How much easier was that than trying to code this into a single thread of code? Yes, there's a little more we need to worry about with FreeRTOS. The library needs some configuration and we need to start the scheduler. Actually, those become largely boilerplate across projects. We do need to think a little about our tasks. We need to give them some memory to work in as a private stack, so have to define that size. There are techniques for guessing that and then diagnostics to test. We also need to think about the task priority, though in lots of applications like this one, we have just written it really doesn't matter greatly. Our 4 tasks would blink the same way even if we had different priorities because there is so much white space where the processor is actually not doing anything. If you'd like to know more about FreeRTOS and all its capabilities to run tasks and communication between them, well, take a look at my FreeRTOS course for the Pico on the Udemy video training platform. For a few pounds, it will take you through the setup of FreeRTOS, the use of tasks and communication between tasks, using semaphores, queues, and message buffers. FreeRTOS Kernel is really useful for helping to solve some problems. It isn't difficult to use or configure on the Raspberry Pi Pico. I've placed the code for my blink example on GitHub, so please check that out. Please also check out my FreeRTOS course on Udemy. I'll put the link in the description. Thank you very much for watching. Please do like the video as it helps others find it. Please subscribe and hit that notification button for more videos from me. Goodbye for now.